Hello, ladies and gentlemen. This is Dr. Robinson again, and we're going to continue our studies. This time we're talking about solving first-degree equations. So here we're going to base our first set of questions on this one. Does 5 plus 7 equal 12? True or false? Well, 5 plus 7 is equal to 12, so I believe that is true. Correct. All right, well, let's move on. Now that we know that's true, let's do something with the 5 plus 7. Let's add 3 to it, and I know 5 plus 7 was 12. Let's add 3 to that side too also. So does that make both sides equal now if I added 3 to it? Well, uh, 5 plus 7 is 12, so that looks like I'm just going to add 3 to it, so that'll give me 15. And yeah, hey, 12 plus 3 is 15, so 15 equals 15. That's true. So I'm going to say that's definitely true. So it did work out. And I want you to take notice, if two equations or expressions are equal and we change each side by addition of the same number, so if we add the same number, your result will be equal. That's interesting. Well, let's try this one. We have, again, 5 plus 7. This time we're going to minus the 8 from that answer. Is that going to be true or false if we have 12 minus 8 on the other side? Well, let's take a look at it. So 5 plus 7 we said was 12, and we're going to subtract 8. 12 minus 8 gives me 4. And 12 minus 8 is 4. So hey, that checks out again. So it's definitely true. So let's check our answer. Yes. All right, so this time we subtracted. So if two equations or expressions are equal and we change each side by subtraction of the same number, so what we did was we subtracted 8 from both sides, that result will also be the same. All right, let's try this one. Uh-oh, we got a fraction here. Does negative 1/2 times 5 plus 7 equal to negative half times 12? All right, well, let's do our scratch work. We have 5 plus 7 inside the parentheses. We work first. That is equal to 12. And we're going to take half, or negative half of 12. So the first thing I'm going to do is take half of 12. Half of 12 is 6. And when I multiply different signs, that gives me negative. So that equals negative 6. And hey, this is the same thing that I have written over here. So since this is the same thing, I'm going to say yes, that's negative 6 also, and that is also going to be true. So this time it looks like we multiplied by a fraction. So we multiplied by negative half. So it's the same thing on both sides. So if we have two equations or expressions that are equal, and we change each side by multiplication of the same number, the result will also be equal. So if we multiply by both sides by the same thing, we're not going to change our answer. It's going to be the same on both sides. Okay, whoa, we got a fraction here, which is with an interesting numerator. 5 plus 7 divided by 3. Does that equal to 12 divided by 3? Well, let's do the easy side first. 12 divided by 3, I know that's equal to 4. So 7 plus 5, yeah, that equals 12. So up here, that's 12. And I'm dividing that by 3. Hey, 12 divided by 3 is 4, and that does also equal to the 4. So I'm going to again say this is absolutely, positively true. Yes. So this one was a little different. What we did was we divided both sides by 3, I noticed. So if two equations or expressions are equal and we change each side by division of the same number, the result it will be equal. So if we divide by the same number both sides, because they're equal expressions or equations, you're going to get the same result. So check your understanding what we just did. If you understand it, great. If you're not certain, rewatch the video, write down your questions, and bring them in. So let's move on a little further. Dr. Rob is thinking of a number. If you add 7 to his number, you're going to get 19. What number is Dr. Rob thinking of? Well, let me show you what it really looks like in algebra. We represent the number I'm thinking of with a variable, which is a letter, and I'm adding 7 to that number that I'm thinking of, and you're going to get 19. Well, here's the key to solve that problem. Work backwards. Undo what has been done using the inverse. Inverse means opposite operations. So in other words, I'm going to work backwards. So I'm going to take what they told me and do the opposite of everything. So I'm going to start with 19, and that equals to plus 7. So instead of plus 7, I'm going to subtract 7 from 19, because the opposite of adding 7 would be subtracting 7. Because what that does, it will undo the plus 7. That'll give me x equals to 12, because 19 minus 7 is 12. And x was the number that Dr. Rob was thinking of, so I believe it is 12. And I can check that by doing a little check over here. So let's do a little check. It said Dr. Rob was thinking of a number. I'll put a question mark there and put a 12, because that's the number we said. If you add 7 to my number, well, let's see what 12 plus 7 is. That equals 19, and you get 19, and that is what we got. So the number we were looking for was 12. So good going. You got Dr. Rob's number. So the key is to undo what has been done using the inverse or opposite operations. So here's a question for you. Dr. Rob is thinking of a number. If you subtract 7 from his number, you get 19. Oh, this time you're going to subtract. So remember, undo what you have started with. So work backwards, and that will get you the answer. So try it. I hope you get the answer. Check your understanding. If you understand what's going on, great. If you're not sure, write down your questions, bring them in, and I'll be glad to answer them. Let's take it a little step further. Dr. Rob is thinking of a number. If you divide by 8, you'll get 2. So what number is Dr. Rob thinking of? Well, I'm going to show you the algebraic equation. So I'm thinking of a number. You divide it by 8, you get 2. So what number divided by 8 is 2? Well, if working backwards is the key and the way of dealing with this, let's work backwards. What's the opposite of dividing? If you said multiplying, that is correct. So I'm going to take Dr. Rob's number that he started with. Instead of dividing by 8, I'm going to multiply it by 8. So that way I can undo the division. And that way the 8's will cancel out, leaving me with the number Dr. Rob is thinking of. He's really thinking of 2 times 8, which is 16. And I can check that by going forward. If Dr. Rob is thinking of 16 and I divide that by 8, I should get 2. Well, 16 divided by 8 is 2, and hey, that does check out. So Dr. Rob has got to be thinking of the number 16. Wow, that's a good trick, working backwards. So work backwards. Undo what was done by doing the inverse or opposite operation. Here's a question for you. Dr. Rob is thinking of a number. If you divide it by 6, you will get 3. What number is Dr. Rob thinking of? Give it a shot. I hope you understand everything that's going on so far. If we're going too fast, rewatch the video. Write down your questions, bring them in, and I'll be glad to answer them in the morning. So let's take it a step further. Dr. Rob is thinking of a number. If you take his number and multiply it by 2, and then add 3, you will get 15. Whoa, we got a lot of stuff going on here. What number is he thinking of? And notice, we're doing 2 things. We're multiplying by 2, Then we're adding 3, and you get 15. This is what the equation looks like. There's Dr. Rob's number that he's thinking of, times 2 plus 3 equals 15. So the key is the same process. Work backwards. Undo the operation by using the inverse or opposite operation. So let's take a look at how we would do that, because we got a lot on our plate here. So we got 2x plus 3 equals 15. So let's undo it by going backwards. So we start with 15. It says plus 3. So I'm going to undo it by minusing 3 from both sides. What that does is cancels out the 3, leaving me with the 2x, 2 times Dr. Rob's number, and I have 15 minus 3 is 12. So I've undone the plus 3. Now I got to undo the multiplication by 2. So instead of multiplying by 2, I'm going to divide by 2, because undoing multiplication will be division. So I divide by 2, and that'll give me the number Dr. Rob is thinking of. So 12 divided by 2 is 6. So Dr. Rob is thinking of the number 6. You better check that. So Dr. Rob is thinking of the number 6. If you multiply his number by 2, so I'm going to multiply 6 by 2, so far I get 12. 6 times 2 is 12. And then I take my 12, I'm going to add 3. So I add 3, 12 plus 3, that'll give me 15. Hey, that does check out. So 15 is equal to 15, so it checks out. So Dr. Rob is definitely thinking of the number 6. Great work. People, if you got that one by working backwards, you are on the roll here. Here's one for you to try. Wait a minute. What happened to Dr. Robert's thinking? It says find the value of R. So Dr. Rob is now stepping up his problems. He's no longer going to give you that. He's going to make you now look at the equation in algebraic form. So solve for R. 7R plus 15 equals 71. See if you can figure out the answer. Here's another one. 17 equals 8C minus 7. You got the 17 here? Well, you can put the equal 17 there if you like. So solve it for C. See if you can figure out the answer. Check your understanding. If you understand so far, you're doing great. If you don't understand, write down your questions, rewatch the video, try it again on your own. Uh-oh, Dr. Rob's challenge me problems. So here's a challenge for those of you who think you are great at this. Dr. Rob's number, I want you to find it. Fraction. 1/2 times Dr. Rob's number minus 1 equals 15. Whoa, that's deep because we got a fraction. I want to share with you a secret. You can get rid of the fraction by multiplying everything by the denominator. So I'm going to multiply everything by the denominator. And I'm going to get rid of my denominator. So the denominator is 2. I'm going to multiply everything by 2. When I multiply by 2, 1/2 by 2, half of 2 equals 1. So in other words, that cancels out, leaving me with just a little r. 2 times 1, or 2 times minus 1, will give me -2. 2 times 15 will give me 30. And notice, there is no fraction anymore. You got a regular equation. And now you should be able to guess Dr. Rob's number, because what we did was we did something called clearing the denominator. There's a video I created about dealing with fractional coefficients, how to get rid of them. Check out that video. So now you should be able to find Dr. Rob's number with ease. So I'll let you finish it off, And here's another question for you. Maybe you'll try that trick again. Solve that challenge me problem. And here's one more. Solve for x. So I hope you enjoyed the video. I hope it was pretty easy for you. I'm sorry if it was a little long, but I'm sure you're going to do well in class. So write down your questions, rewatch the video, give us a thumbs up on YouTube, and I'll see you in class. This is Dr. Rob. Bye-bye.